So here we go, the starter. This is actually taken from the challenge questions in the textbook, but that doesn't make it any less useful. So here we go. The graph shows the velocity of an object travelling in a straight line during a 10-second time interval. How long did the object take? After how long did the object change direction? Work out the total distance travelled by the object. Work out the displacement from the starting point of the object after 6 seconds and 10 seconds. So this is testing our understanding of velocity time graphs and the words velocity, distance and displacement. So the key thing to remember is that velocity is a vector quantity, so it has direction. Displacement again is a vector quantity, so again it's got magnitude and direction. And distance is a scalar quantity, so it's only got magnitude. So if we apply that to these questions, part A, after how long did the object change direction? Well, for this section of the graph here, the velocity is always positive. And then when we get to this section here, the velocity becomes negative. So part A, it changes direction at t equals 6. So it changes direction at t equals 6. So up till then it's been moving away, and then after then it moves it back in the direction it started, back towards the origin, if you like. Total distance travelled. So again, distance is magnitude. So distance is magnitude, so that's just the area under the graph. Area under graph. So if we call that 1, area 1 is equal to, well, it's a trapezium, so it's the height, which is 3 over 2 times the sum of the parallel sides, which are 6 and 1, coming from here. So that's 6, that's the 1, and that's the height. So area 1 then is equal to 21 over 2 metres. Area 2, so that's going to be this bit on the diagram, using the same rule, the area of a trapezium. The height now, I know it says -2, but the height is 2 over 2. And the parallel sides this time from 6 up to 10 is 4, and from 8 up to 10 is 2. So we get 6 metres. Therefore, total distance travelled equals 21 over 2 plus 6, which is 12 over 2, which gives us 23 over 2 metres, which you might prefer to write as 11.5 metres. Part C. Work out the displacement from the starting point of the object after 6 seconds. Okay, well, we've already done that. Part 1, displacement at t equals 6 is, that's area 1, which is 21 over 2, or 10.5 metres. I can see I've made a silly mistake up here. 21 plus 12 is 33. So that should have been 33 over 2. And that should have been 16.5. Sorry. Okay, part 2. Displacement at t equals 10. T equals 10 is, well, area 1 minus area 2, because area 2 is going in the opposite direction. We've already said up here that the velocity at that point is negative. Yeah, so I've got negative velocity there, positive velocity here. So the displacement is going to be area 1 minus area 2. So we get 10.5 minus 6 is 4.5 metres.